Now we're going to turn to the main goal of the exercise, namely to build a parser for the expression language. So now the purpose here is to build a function which will take strings as input, strings containing the representations of expressions, and turn them into elements of this data type. So there are many ways in which one can represent this particular data type as a grammar. And exactly how you do that will determine how easy it is to write a parser, because the structure of the parser will follow the grammar very much. And what makes a good grammar for parsing and what doesn't is sort of something that we don't really want to get into the details of here. So I can just sort of tell you that this is a good representation of the grammar for expressions, arithmetic expressions, which divides arithmetic expressions into these various components, namely terms, things which are added together, and factors, the bits which are multiplied together. And those basic factors are numbers or a bracketed expression. And so by parsing using this particular grammar, our job is going to be made a lot more easy, because it will be relatively unambiguous what to do with the terms. So as I say, the functions for parsing these things will follow the grammar. We will use functions for choice to represent the choice in the grammar. We will use do notation initially, at least, to represent the sequence of things. For example, first a bracket, then an expression, then another bracket. And we will use combinators like 0 or more, 1 or more, for representing these sort of iteration operations that we see here. So let's dive straight in and start with a parser for expressions. So an expression is a term followed by 0 or more plus terms. So because we're going to sequence things, first do a term, then do 0 or more something else, I'm going to use a do block to represent that. And the first thing is to use a term to parse a single term, and we're going to write a parser for a term. So I haven't written it yet, but I'm going to use it in the definition of expressions. So this will be a parser for a single term, and let's call the term we get from that t. So we're going to use the term parser to get a term. We'll call that term t. So next step will be to use the 0 or more parser for these additions. And let's just for now call that adds. We haven't written that, but that's a parser for something of this shape. And we'll call that ts. And we need to write the last line, but let me just write in the missing parser. It's a parser for first parsing a plus symbol, and then when you parse the plus symbol, then you're parsing a term, and that's the thing that we're going to return. We're going to return the term that we parsed. So basically, when we parse this thing, what we're going to end up with, the strategy here, is to create a list of terms, and then at the end, we're going to convert that list of terms into an expression. And we're going to do that by combining them all together using the add constructor to build one big expression from the various small expressions that we've obtained. So we've obtained one expression here, recursively. We've obtained a list of expressions here, and now we're going to combine them all together. But in order to do that, of course, we need to finish adds. And of course, what I wanted to get to here was that we simply recursively, we're calling the term parser. So this is parsing one plus character followed by a term, and what this returns is the term that you obtain. Let's get the indentation there. Okay, and so the last line then is we've got to take the various pieces that we built, namely the first term and all the list of the rest of the terms, and combine them all together into one expression. We're building an expression here. And the way that we can do that is to combine them all by folding them all together using the add constructor of the expression data type. So we're going to use a fold L. I'm going to do it left recursively. The first argument of fold will be the function for combining things. We're going to use the add function of the data type, combining two expressions into one. The base case that we can take will be the first term that we took, and the things that we're combining all with that first term are the things that we found by using 0 or more. And let's just compile that and make sure that I haven't made too many mistakes. I have made at least one mistake. Okay, so the error here is that it was expecting a parser for expressions and it got an expression. So I've built an expression here, but of course I need a parser for expressions. So how do we turn a single expression into a parser for expressions? Well, this is the result that we want to return from the parser. So we simply use the return of the monad. This takes a thing and turns it into a parser for things. And of course, it's a trivial parser that always returns what it is. Okay, so we could have written this function adds that we use 0 for parser that we use 0 more times in line here rather than define it down here. One way to write that on a single line is to use a semicolon here. So we do a character followed by, let's put it all on one line, followed by a term. Then we don't need the local definition at all. Okay, so that's the parser for expressions. We can't test it yet because we need to finish all the others because they're all interdependent. If you remember the grammar here, expressions are defined in terms of terms, terms are defined as factors, factors are defined using expressions. So we can't really test anything until we've done all three. But fortunately, a term is very similar to an expression. And in fact, it may be tempting again to cut and paste here, but it might be a good idea to try and split them up. I'll do that in a moment. Let me just get the thing working first. We'll just do the cut and paste, and then we'll refactor in a little bit. So a term is 0 or more, not terms, but factors. So we take a factor, and we take 0 or more factors multiplied by each other, and then we combine all of the results together using a fold. And finally, a factor. Let's go back to the grammar for factors. We can get on the same page. So the grammar for factors is either a number expression or a bracketed expression. So it's either a number expression, and we have a parser for numbers. So the parser for numbers is called number, but that's an integer parser. That parses an integer. We want to parse an element of the expression data type. So we can turn an integer into an expression using the constructor num. We can't apply num directly to that, but we can map it with the fmap operator. So that's one of the possibilities. The other possibility, using the alternative combinator, so it's either num or, and here we're going to just write a do block, and the do block will be maybe put it on the same line here. So the do block will first read a left bracket character, and then we're going to read an expression, which we will call E, and then we will read a right bracket character and return the expression that we constructed in the second step. Okay, so let's compile that and just fix a few errors. So it's not return E, the expression that I got from the expression parser. And let's see, and then we have it. So now we should be able to parse an expression using the expression parser. So we parse using the expression parser some expression like 1 plus 2 times 3. So we expect that thing to be an addition of two things. Sorry, we expect this thing, yes, to be an addition of two things, 1 and the multiplication of 2 and 3. It's the addition of 1 and the multiplication of 2 and 3. Whereas if we put some brackets in, let's check that it actually does this correctly, that should be a multiplication of two things, namely the addition of 1 and 2 and the number 3. And in both cases there's no junk on the end. And just to double check, we can put junk on the end because that's the way this one works. It allows us to have stuff on the end. Might be useful if we extend our parser with some other things. But if we, for example, start with something that's not in our language, then we get nothing. Or, for example, if we delete one of the brackets, we don't get a proper expression.